Alright, we're back. This is section 3.8, problem number 8. And the question states, if y equals the square root of x, parentheses, x plus 3 in parentheses, then find dy dx using logarithms. And I honestly couldn't believe what I was reading here. If you ever see this problem, don't use logarithms. It's a waste of time. But they're just trying to have you develop skills for working with logarithms because there are a lot of derivatives that you will need logarithms for. So first I'll show you how to do it using logarithms, and then I'll show you the way that I would probably use if I was just asked to find the derivative here. So the first thing when we're going to work with logs here, natural logs are the easiest to work with. Whenever you see logs of any other base, convert them into natural logs using the change of base rule. If you just look that up, it'll show you that you can write log base A of some thing B. That can be written as the natural log of B over the natural log of A. So you can write it with the natural log of the base, and then whatever's in the log, the natural log of that, over the natural log of the base. So that's called change of base. There's a couple other logarithm rules, the product and quotient rule, which are not to be confused with the differential product and quotient rule. But they're definitely important, and they can be useful in some problems. So for this problem, we're going to start by taking the natural log of both sides. And I'm going to rewrite this as 2 to the 1/2 instead of under the root. So I'm going to write this as, we'll write it like this. Natural log of x times x plus 3 to the 1/2 power. Here's another log rule. It's called the power rule for logs. Once again, not to be confused with the derivative rule, the power rule of derivatives. Anyhow, what the power rule of log states is that, let's say that I have some log a of b, and that b is to the power x. So log base a of b to the power x inside the parentheses, that can be written as x log base a b. So in other words, you can bring down the exponent from up here to the front of the log. And so we're going to use that right here. So we're using the power rule, bringing down the 1/2 in front of the log. So 1/2 ln. I'm going to go ahead and distribute because there's no reason in doing unnecessary work. So this is x squared plus 3x, or plus 3x, yeah. Alright, equals ln of y, and now we use implicit differentiation. So we take the derivative with respect to x of both sides. I'll try to fit it in here. And so on the left-hand side, how we derive natural logs is we just write 1 over what's on the inside. So the inside is y, so we write 1 over what's on the inside. But we also have to follow the chain rule here, and because y is a function of x, we have to multiply on the derivative of the inner function, which is y, so dy dx, equals, once again, the natural log derivative is 1 over, so the 1/2 can hang outside, and then we're multiplying that by 1 over what's on the inside, which is x squared plus 3x. But we still need to abide by the chain rule, so we multiply by the derivative of the inner function using the power rule, which is 2x plus 3. And at this point, we need to get the y over here, because remember, we're looking for dy dx, so we need to get the y over here. So dy dx will multiply both sides by y equals 1/2. Well, actually, I'm going to write it as y, because we multiplied y over y times 2x plus 3 all over 2 times x squared plus 3x. And so we're almost done. We just need to go back to our function and plug it in for y. That way we have it in terms of x. And so, I'll make some room here. When we plug in y, we'll find that it's going to be, I'm going to distribute this again, so x squared plus 3x to the 1/2 power. And y is multiplied here, or I'm sorry, that is y. We just substituted y for y. So timesing by 2x plus 3 all over 2 times x squared plus 3x. And you'll notice right away that we have some like terms that can be canceled using division. And so this is to the power 1, and when we divide powers we subtract. So 1/2 minus 1, well that's minus 1/2, or otherwise you could look at it as 1/2 in the denominator, and that cancels out. So something to the power 1/2 over 1, 1 minus 1/2 is minus 1/2, which is a 1/2 on the bottom of the fraction. So at this point we have the answer, and it was kind of painfully long process compared to what it needs to be. Definitely you'll want to know how to use logarithms, and you'll definitely want to learn how to use them for reasons when they're actually necessary. But in this specific case, what I would have done, even if it was on a test, it's just not worth using logs. This problem just isn't worth using logs. So start with the same step of distributing the x into the x and the 3. So x squared plus 3x, and that's all to the 1/2 power. Now it's just a power rule and a chain rule. So dy dx equals this side, the derivative with respect to x. Using the power rule, we bring down the 1/2. We leave the inside the same. We subtract, because the power rule 1 from 1/2 gives us minus 1/2. And then we multiply the derivative of the inner function, which is 2x plus 3. And we're done. So it's good to practice using logs. I just kind of wish they would have actually had a problem that you needed to use logarithms for, because there are a ton of problems where logs are necessary. This is definitely not one of them. Anyhow, I hope this was helpful, and I'll see you next video.